In this video, we will be looking at triangle trigonometry, and we'll look at how to solve right triangles. This is a continuation from previous videos, except for I want to add a flow chart on how to solve trig problems. I realize with some feedback from students that there's a need to get an understanding of, if I'm given a problem, where do I start, where do I go with it? Well, first off, what we want to do is ask yourself, is the triangle a right triangle? So in this case, all of these videos are going to be, or at least this video, the answer is going to be yes to answer all of those. We will be looking at if the answer is no in other videos later on. But so for right now, we're going to look at the answer is yes, and then so you want to ask yourself, does the question involve any angles? So is there an angle that is given? And if so, then we're going to be, then you can use trigonometric ratios. So if you remember, sine A over side A equals sine B over B equals sine C over C. And so that's the trigonometric ratio. If there aren't any angles, and if you're just given, and it's a right triangle, and you're given just sides, then remember you can use the Pythagorean theorem, which is c squared equals a squared plus b squared. And like I said, we'll be looking at these in future videos. So we're going to look at how to solve right triangles, and you're going to be given some questions, and you're going to need to really look and see if you can answer the following combinations to know if you can use the trig ratio. So is the length of one side and the measure of an acute angle? Are you given at least the length of one side and the measure of an acute angle? And of course you also have the 90-degree angle. And then if you're given the length of any two sides, and again you're going to be given at least a 90-degree angle because you know it's a right triangle. So if you have those, then you can move on to using the trigonometric ratios. So let's go ahead and practice this a little bit. And we are asked to find side A in the triangle. So we're asked to find side A right here. So first off, ask yourself, is it a right triangle? Yep, it sure is. It's got the 90 degrees right there. And does it have any angles? Does the question involve any angles? Yep, as a matter of fact, we have this angle right here of 50 degrees. And so being an angle of 50 degrees, for angle B, we will be able to work on solving this problem. So if the answer is yes, to having any angles, and we know we can use the trigonometric ratio. Now we have to say, okay, which trigonometric ratio are we going to use? Well, what are we given first? Okay, let's make sure that we understand what we're given. So we are given the angle, as we pointed out. We're given the hypotenuse of 21 degrees, or excuse me, 21 centimeters. It's the length, and so we are given 90-degree angle right here. So being given all of that, we will try to see what we can work with, because we're being asked to find A. And A is the line that is adjacent to the angle that we've been given. So knowing that we have the adjacent angle and we have the hypotenuse, that should trigger something right there, and you should be able to say, hold on, I recognize that whole SOHCAHTOA thing from before. Adjacent and hypotenuse, that means then that if I have the adjacent and I have the hypotenuse, I can use cosine. So knowing that we can use cosine, let's find side A in the triangle that is right here. So let's see. So we're going to use cosine of 50 degrees, because that's right here. This is cosine of 50 degrees equals the adjacent over the hypotenuse. So adjacent, we don't know that. That is A over the hypotenuse, which is 21 degrees, or 21 centimeters. And so let's go ahead and get A by itself, and so we're going to multiply both sides by 21. That's going to cancel this side out. And get the calculator out, and make sure it's cleared of everything else. We're going to go 21 times, and this will look a little bit different for you maybe than the way that I have to do it for being able to find cosine. Make sure you hit cosine and not sine or something else. And you should come out with that A equals 13.499 centimeters. And if you round that up to significant digit, it'll be 13.5 centimeters. Okay. Let's go ahead and look at the next one. And again, we want to run through the flowchart and and just figure out what we've got here. And so, is the triangle a right triangle? Yep, it sure is, right there. And does it have any angles? Yep, it sure does. It's got an angle right there. Also has the right triangle, but there we go. We know we've got angles here. And so now we want to figure out, okay, so what are we given then, knowing this? So, well, let's see. We know we've been given in this problem that we've got an angle, and we've got an adjacent line right here of 16.5. Don't know the unit. And we have an opposite side over here of 11.3. And we're going to name this opposite side A, because we have the opposite of angle A, and I'm just going to name this side B, just so that we've got a reference. And so, but we don't know what the angle for B is, but we can find that. But what we really want to find is what's the measure of angle A. And so let's concentrate and stick with that one. Since we do know the adjacent angle and we know the opposite, or not adjacent angle, the adjacent side and the opposite side, that should trigger something going on with adjacent and opposite. And, oh, there we go. So adjacent and opposite says, let's use the tangent trig ratio. And let's go ahead and use that to be able to solve this problem. So we're going to say, all right, tangent A, which we don't know, so it's going to be our variable, is the opposite over the adjacent. So opposite 11.3 over the adjacent 16.5. So now let's go ahead then and follow our rules of math, and just, the problem says to divide it because it's got that division symbol right there. So 11.3 divided by 16.5 gives us 0.68484848. Okay. So, but that's not it's asking for A, which is an angle, and this is still in tangent of A. So remember, if it's still in tangent of A and you want the actual angle of what it is, just go to your inverse and make sure you're using the correct function and use tangent. And the angle is 34.4 degrees. So let's come back and look at this and see. All right, so that says that this angle right here is 34.4 degrees. All right, and from there we could solve the rest of them as well, but it's not asking us to. So let's go ahead and look at the next problem. So looking at this problem, I want you to be able to first try to figure out how you would figure out, don't try to solve it, but just read the problem and take a minute. You can stop the video and try to figure out how you would figure this problem out.
Okay, so this is a bit of a logic problem. So we're going to walk through the steps here, at least of what they are saying to do it. And imagine what they're saying is it's a perspective of the person who's actually doing the measurement. So you've got a tape measure and you've got a protractor, but you can't get the tape measure across the river. So the first thing you could do is stand below your point A down here and point C, and you would take a look and get a straight line for A and B. Okay, well, that makes sense. So the next thing that you would do is you would want to continue your triangle to try to line up A with another point along the shore that is perpendicular to it, so a 90-degree angle. So remember, you have a protractor, so try to figure that out. And then now the next one, I got a funny feeling you could probably imagine the next thing you're going to want to make a triangle, and so you're going to stand a little bit down below, and you're going to go to point E down here, and you're going to line up point D and B, and you're going to have a right triangle formed. All right. Well, now that you've got your triangle BA, AF, or AD and DB drawn, then you can go ahead and, with a little bit of information, try to figure out what that distance across the river AB is going to be without stretching your tape measure across there. So looking at this, going over the flow chart of, that we've been using, pause the video, try to figure out how you could figure out line AB. Okay, great. Hopefully you've solved the problem, and we're going to go through this, and if not, feel free to pause if you're like, oh yeah, that's right, I can figure it out from here. So looking, we know one thing. We know that, let me get this off of here. We know that line AD, it says, is 105 feet. Okay, and that angle D is 49 degrees. And what we're looking for is I'm going to call this little d because it's the line opposite from the angle that we have. And so that's kind of a clue right there as we go through the flow chart. Is this a right angle? Yes. Does it have angles? Does a problem have angles? Yes. So if it has angles, we know that we're going to be using some sort of trigonometric ratio. And I just said that D, line D, is opposite of the angle, and 105 feet is adjacent to the angle. So if we say, okay, we've got an opposite side and we have a adjacent side, then if we're using those terms opposite and adjacent, then we know that we can use tangent. So we'll use the tangent ratio, and let's go ahead and write this out then. We'll say that the tangent of 49 degrees equals the opposite over adjacent. And so opposite, we don't know. We called that D. And over adjacent, and that's 105. And so we want to get D by itself. So we will multiply 105 times both sides. That will get that out of there. And let's get the calculator. And we'll go 105 times tangent of 49, and close parentheses, equals 120.79 feet, and that is D. So that's D, and so we'll come over here, and we'll go, all right, does this look like it might make sense? 120 120, we'll call it 121. We'll go to the significant digit. And so 121 feet from here to get across the river. Yep, that looks like that works. So you figured it out. And that is the end of this video.